Okay, listen. So today we are going to discuss about output equation of single and three phase transformer. So in that you have to consider first the EMF equation of single phase transformer. That is the E, it should be equal 4.44 into F into pi m into T, right? F is the frequency and T pi m is the maximum flux and the T is the number of turns. That we all know, you may already studied in the lower class, right? So the voltage per turn, so ET it should be equal to induced EMF E divided by number of turns, it should be equal 4.44 into pi into F, pi m into F. Okay, so here the T it may getting cancelled. Then the total copper area in the winding. So the total copper area in the winding, you have to consider both primary winding as well as the secondary winding. For the single phase, you can consider the total copper area in the primary winding and total copper area in the secondary winding alone. For three phase, you have to multiply it with 2, right? So here, if it is single phase, it may come like that. If it is you are considering the three phase transformer, you have to multiply it with 2. So total copper area in the primary winding, it should be equal number of primary winding, number of turns in the primary winding into the area of the primary winding. While you are calculating the area, you need to consider the primary current as well as current density. So the area of the primary conductor, it should be equal AP, it should be equal to IP divided by del. IP is the primary flow of current, del is the current density, that is the area of the primary conductor, right? Similarly, the secondary conductor also. So suppose if you are considering the single phase, there is the options of 2, you no need to multiply 2. The total copper area in the winding AC, it should be equal to IP as well as TP, because you are substituted the AP equation in the previous expression. AP it should be equal to IP by del, that you have to substitute and the equation is getting modified. So the common term is del, that you can take it outside. So the 1 by del it should be equal to IP into TP into IP plus TS into IS. So the number of turns in the primary winding, flow of current, and number of turns in the secondary winding and flow of current in the secondary winding. So if you are using in the single phase, there is the options of the 2. So 1 by del. If it is three phase, you are multiplied with the 2, so the 2 by del it will come. So first you can consider the single phase, the 1 by del you can take it outside. This is the that is the magnetic MMF, that IP into TP it should be equal to AT. Okay, so you can consider, you can replace this two term into commonly AT. So the 2AT it will come. So for the case of single phase, AC it should be equal to 2AT divided by del it will come. For the three phase, 480 divided by del. Okay, that is the single phase means 280 by del. For the case of three phase, 480 by del. Okay, so now you can consider the phase factor. The phase factor it should be equal the total copper area to the total winding area. The phase factor is defined as the ratio between total copper area to the total winding area. So the kW, sometimes we can mention some other notation, S suffix x, S suffix f, but here we are used the kW, that was the phase factor, AC divided by AW. So the AC means the total copper area, that already we found it both three phase as well as single phase. Then here the AC it should be equal kW into AW. The kW is the phase factor, AW is the total winding area. So the both the AC, the equation B as well as the equation A, the LHS side both are common. So the RHS side we can equal it. So kW into AW it should be equal. For the single phase, 280 divided by del it will come. For the three phase, 4 into 80 divided by del it will come. So the 80 it should be equal kW AW del divided by 4. For the three phase, 80 it should be equal kW AW into del divided by 2, that is for single phase. Okay, now we are considered for the rating of the single phase transformer. The VP IP into 10 power minus 3. VP we can consider as EP, because here the induced EMF, the induced EMF it should be equal number of induced EMF into turn as well as number of turns in the present in the primary winding. Here we are considered the primary winding alone. So the ET into TP as into IP into 10 power minus 3. We all know we all know that IT into T. Okay, IP into T, it should be the AT. So here we are consider this equation. Similarly here it may getting modified into AT. So the AT value we obtained here, the kWAW into del divided by 2 for the single phase. So that you are substituted here, then we can eliminate it, and finally we obtained the expression 2.2 into F into pi m kWAW del into 10 power minus 3, right? This is for the single phase. We all know that is the maximum flux density, or it should be equal pi m divided by to maximum flux divided by the area. This is the common formula we may study in the lower classes. So the Pm it should be equal pi m by A, but here the pi m is there, so the pi m it should be equal Bm into AI, that is the iron area. So the Bm pi m you can replace Bm into AI, that you can replace it, then you obtained the final expression, the revised expression, the 2.22 into F into Bm into AI and kWAW into del into 10 power minus 3, that is the output equation or rating of the single phase transformer. Similarly, if you are considering the three phase, this expression you have to multiply it with the 3, so the Q it should be equal 3 into Vp Ip into 10 power minus 3. The same procedure you can replace into Vp into Ep, then Ep into Et, then you can substitute Ip, also Ip into Tp you can modify into At. So the AT value we obtained in the three phase, so that is the kWAW del divided by 4, that you can substitute and you can eliminate. Finally you obtain the expression 3.33 into F into pi m into kWAW del into 10 power minus 3. So again the pi m you can replace it and you can obtain the final expression. The only thing is the constant multiplication, here it is coming 3.33, but here 2.22. Okay, this is only the variation between the single and three phase. That's why I comparatively consider the both single and three phase transformer. So we obtained the rating of the machine both single and three phase. Okay, if you have doubt you may ask.